Welcome to our channel Circuits Analytica. In this video, we will discuss the application of Kirchhoff's voltage law. For the following network, find the value of current Ix after combining the voltage sources and resistors. The network on the left hand side is redrawn as shown in the right hand side. So 120 volt and 30 volt sources are connected in series. So this is the sign convention of voltage and current sources. So here voltage V, which is shown on the left hand side, is redrawn as shown on the right hand side. That becomes minus V after reversing the polarity of the voltage source. Similarly, current source I can be represented as minus I flowing in the opposite direction. So here 120 volt and 30 volt are in series. The 30 volt source can be replaced as minus 30. So effective value becomes 120 plus minus 30. 120 minus 30, that is equal to 90 volt. Now we can combine the two resistors of values 30 ohms and 50 ohms which are connected in series. So this combination can be replaced with a single resistance of value 45 ohms. To find Ix, apply KVL in the loop. Applying KVL in the loop, we will get 90 minus V45 is equal to 0. So here direction of current flow is shown in the clockwise direction. When we consider 90 voltage source, as we move from negative potential to positive potential, 90 voltage source should be taken as positive. And when we consider voltage drop across 45 ohms resistor V45, as we move from positive potential to negative potential, that voltage should be taken as negative. So when we apply KVL, that results in the equation 90 minus V45 is equal to 0. So according to Ohm's law, V45 is equal to 45 into Ix, where Ix is the current flow through 45 ohms resistance. Therefore, we can write 90 minus 45 Ix is equal to 0. That means 45 Ix is equal to 90. That means Ix is equal to 2 ampere. Thanks for watching Circuits Analytica. Enjoy learning.